大家好，呃，我们接着来说，这些重要概念的下一个部分。这个部分呢，在字典的 F 到 L 之间，我摘选了，这些概念呢，其中这一部分比较重要的是学习，还有就是信息这两个概念。这两个概念啊。我是分别从3到4个角度，每个都是3到4个角度来解读的。呃，如果有兴趣的同学可以回顾一下这本书的原文，就是这本书《Dictionary of Cognitive Science》。好，咱们开始回顾这些重要的概念。Function. The term function in neuroscience refers to a set of active, dynamic properties that are competes to achieve the same goal in a living being. Functionalism. Functionalism is the name of a popular philosophical strategy with regard to the proper analysis or definition of mental phenomena, mental terms, concepts, properties. It is based upon the simple idea: many things in the world are what they are, not particularly by virtue of what they are made of, but by virtue of what function or role they serve in the system. Fuzzy 实际上是代表模糊的意思。Fuzzy 在人工智能里头有非常非常多的运用啊。One of the difficulties ordinary logic has in representing knowledge comes from the fact that calculating a truth value necessarily ends with either a true or a false, even though many situations call for verdicts in shades of gray. We know how to assign a gradual merit to propositions, the probability. However, while probability is considered suitable for representing uncertainty, other techniques are deemed necessary for imprecise knowledge, if for no other reason than because calculating probabilities is too complicated to be compatible with the cognitive processing of this kind of knowledge. Goal. Intuitively, a goal-directed behavior is one that is executed in view of attaining a certain goal. The realm of living things exhibits innumerable examples of goal-directed behavior, such as web spinning by spiders, courtship rituals in birds, dam building by beavers, and so on. The difficulty inherent in this concept, however, is that it seems to imply a type of final causality in which the desired result is what orients and guides the action. Goal-directed behavior thus seems to necessarily involve the representation of a goal or purpose, and a number of studies have shown that goal-directed behaviors can be manifested independently of any type of representation. Grammar 实际上在人工智能领域也有，在语言学里也有，但是 grammar 这个概念还是挺广泛的啊，就是我们还是需要从多个学科去理解这个概念。The term grammar refers to both a familiar object and an ancient activity. Panini's grammar of Sanskrit dates back to 500 before the Common Era. In its descriptive sense, the term refers to the set of all phonetic, morphological, and syntactic regularities observable in a given language, along with the representation of those regularities. When someone speaks of a language with no grammar, the language in question can only be one whose rules have not yet been described. In its normative sense, generally criticized by linguists, grammar is the set of conventions defining a dialectical variant deemed by the society to be superior and chosen as the one to teach. Don't say "with John and I," say "with John and me." Or don't say "I just seen him," say "I've just seen him." In its linguistic senses, grammar is either the analysis of the observable regularities of a given language, for example, the grammar of French anaphors, or the theoretical model used to conduct such an analysis. syntagmatic grammar, functional grammar, etc. The advent of generative grammar added another meaning to the term. According to Noam Chomsky, a grammar is a model not of existing languages, but of the faculty of language, that is, the ability of every child to learn and to speak any language. Although the term has been overextended to refer to any system of regularities, as in the grammar of the cinema or the grammar of behavior, it should be reserved for linguistic entities. Holism 实际上是和还原论相对的一种观点。Holism characterizes any theory whereby the properties of the whole cannot be predicted or explained from the properties of the parts. 下面就是我结合了多个学科完了摘选的一些关于信息比较重要的内容啊，大家可以重点看一下，我读慢一点。In cognitive neuroscience and psychology, all input or output to and from the subsystems of a functional architecture is information. The neuroscientist's task is to specify the nature of that information and the mechanisms that transform it within each subsystem. At the neural level, neurophysiologists have long assumed that the information content of a neuron is represented only by its discharge frequency, that is, the number of action potentials it sends to its axons within a given period of time. An alternative view today contends that it is the temporal pattern of discharge that contains the information. In other words, the different patterns generated by variations in the discharge frequency over time may themselves carry information. The meaning of the term information in information technology is directly inherited from Shannon's information theory. Suppose agents could communicate only by means of messages composed of symbols taken from a given alphabet A. The arrival of message M is likely to inform its addressee that one of the M possible events has occurred. The amount of information, I, transmitted by M is considered to increase as n increases. It is customary to choose the base 2 logarithm of n as its increasing function, that is, log base of 2 of n. One can easily show that if A has n symbols, and if the length of M is k, then n is at most equal to nk, so I is less than or equal to k times log base of 2 of n. If the alphabet has only 2 signs, that is, n equals 2, a common case in today's computer technology, we have I is less than or equal to k. That is, the amount of information contained in M expressed in the binary language is at most equal to its length. The unit of measuring information is the bit, abbreviation for binary unit. This definition implies that any series of k symbols taken from the same alphabet carries the same amount of information. But this is counterintuitive for various reasons. First, agents will feel that they have received more information if the answer announced in M was unexpected than if it was predictable. Shannon's theory offers a remedy to this drawback by authorizing messages of variable length in such a way that the shortest ones denote the events that are the most probable. Second, a message formed by a million consecutive A's is not as informative as a book of the same length. This difficulty can be overcome by considering, as Kolmogorov did, that the amount of information conveyed by M is dependent not upon the probability of what M announces, but upon the complexity of the simplest mechanism capable of generating M. Finally, and in particular, as far as the cognitive sciences are concerned, the definitions of information given by Shannon and Kolmogorov did not consider the effect produced by the receiver on the receiver. Yet, if M is written in Chinese, it will be judged less informative by an agent who does not understand that language than by one who does. 看完这个词条的这一些信息啊，一个非常直接的一个话就蹦出来了，大家一定要首先学好自己的母语，然后学好英文。为什么呢？这是根据信息论给大家的一些指点吧。因为就是你越有效的传达一个信息，它越能表达更多的内容。所以在心理学研究里头，大家可以看到啊，有一些结论叫做 less is more， 这个实际上是在决策领域里头经常能听到的。同时呢，如果大家在一些尤其是一些语言学背景的一些小伙伴啊，他们也许在学校里经常能看到这个安南说的一句话，还是曼德拉呀，我忘了，应该是曼德拉吧，说的一句话，就是说，如果你说他会说的语言，那是一种情况；如果你说他的母语，那又是另外一种情况。所以大家一定要学好自己的中文，同时在学术交流方面要学好英文，这个是非常非常重要的。这也是信息论这一个非常经典的理论，给全世界人们带来的这个非常好的一个寓意。Inheritance. The notion of inheritance in knowledge representation first began to develop in the field of semantic networks, where it was used for organizing information into inheritance hierarchies of the type sort of or kind of. Since then, inheritance has become a fundamental part of object representation and object-oriented programming. In an inheritance-based system, concepts are classified hierarchically. The most general concepts dominate the more specialized ones. For example, vehicle can be seen as a more general concept than automobile, and as a more specialized concept than physical object. This type of classification is found in all large-scale knowledge representation systems. Knowledge acquisition. Knowledge acquisition is studied in several disciplines of the cognitive sciences, particularly in psychology, where the topic is addressed in research on learning and cognitive development using a symbolic and/or connectionist approach. In artificial intelligence, the utility of a knowledge-based system, or KBS, depends for a large part on the richness and quality of the knowledge it contains. The construction of a KBS thus necessitates acquiring knowledge specific to a given domain of application. However, it is not easy to elicit knowledge from experts in the field, precisely because they're usually completely unaware of most of the mechanisms underlying their expertise. It is therefore important to have methodologies and tools to assist in acquiring this knowledge. Knowledge base. In artificial intelligence, a knowledge base is not a piece of software, but a body of compiled information to be used by a computer program, the inference engine. Language. The ability to master language, a faculty specific to the human species, is an extremely complex process that necessitates the participation of a large number of functional subsystems. We shall look here at the contribution of cognitive neuroscience to the study of language production and comprehension. Current research into brain-language relationships is showing more and more often that these two aspects of language mastery are tightly intertwined. Since the 1960s, it has been possible in AI to use natural language to query databases of facts and the systems that can solve word problems of the kind found in school books. Although we are still far from having a machine capable of truly understanding, some systems can be accredited with a basic level of comprehension. Most of these systems break down the comprehension process into modules, a choice probably based on the desire to model human cognition or perhaps simply on computer-related constraints. When the input is in vocal format, the initial modules process the speech signal, segment it, and propose an ordered list of possible phonemes, and for each segment, these segments are then connected in order to make words in the lexicon. Certain systems, especially those derived from Gestalt theory and/or connectionism, perform global recognition. If the input is a text, a morphological lexical module identifies words by applying, for example, the inflection and conjugation rules of the language under consideration. 下面是一个是学习这个概念啊，学习这个概念，其实在心理学、在神经科学、在人工智能啊，以及在这个语言习得呀，还有包括哲学方面，都会有非常非常多的这个阐述。我这里面摘的是前三个，大家可以去体会一下，现在机器学习，包括深度学习这些人工智能类的技术，在各个学科的应用有多么的广泛。大家一定要好好的理解一下这个概念。我读慢一点。Learning refers to a modification in the ability to accomplish a task, brought about by an interaction with the environment. It differs from a behavioral change that occurs through maturation, that is, internal evolution of the organism following a developmental program characteristic of the species. Two major types of learning are generally distinguished, depending on the level at which the psychological processes are integrated into the cognitive system. Elementary, stimulus-driven learning, that is, imprinting, habituation, classical conditioning, operant or instrumental conditioning, and complex, representation-mediated learning. The former is largely determined by the physical characteristics of the environmental stimulus and is contingent upon such factors as contiguity, repetition, intensity, and predictive value. The latter is dependent upon the meaning of subject attributes to the stimulus. It brings symbolic representations into play and leads to stable modifications of representations stored in memory. In cognitive neuroscience, it is conventional to distinguish between two types of learning, according to whether implicit or explicit memory is involved. Each type calls upon different brain structures. Skill learning involves an adaptive modification of behavior achieved through task repetition. This type of learning is considered to fall into the implicit memory category, in that it is manifested through behavior. Improved performance across training sessions and occurs without the subjects being able consciously to recollect the learning episodes. The learning that takes place in intentional memorization situations, such as memorizing a list of words, a shopping list, or a poem, is of a different nature. This kind of learning, called intentional learning, is considered to depend on explicit memory since it can be expressed via language rather than solely through behavior, and the learning can state when and where the learning episodes took place. The crux of AI is the study of the mechanisms likely to enable a machine to make good use of its experience, that is, to learn. This line of research is aimed first and foremost at building machines capable of adapting and acting more efficiently, but that is not all. Another AI task is simulating certain aspects of human or animal learning, such as simulations improve our understanding of the learning process. Despite their common goal to acquire knowledge, the functions and mechanisms of learning are multiple and varied. For simplicity's sake, let us begin by distinguishing four major learning functions. 1. Learning involves memory storage and organization, such that memories can be retrieved at the opportune time. 2. Learning involves the acquisition of concepts. When given different examples and counterexamples of a category, for example, table, scalpel, carburetor, a very general function is launched in to differentiate between the example and the counterexamples in each category. 3. Learning is based on the compilation of know-how. A task executed several times is accomplished faster, since the same errors are not made and the same hesitations are no longer needed. Accordingly, once it has executed a task, a machine should be in a position to draw from its experience in order to work more quickly. 4. Finally, like human beings, a machine should be capable of inventing new theories to explain or summarize a body of facts or a series of events. This is the most difficult operation of the mind to figure out and the most exciting objective that can be set. 所以这个最后，如果是人工智能出身的小伙伴，看一下这四个层面，看看是不是这个4个问题都很重要，可以在每一个层面，然后去按照科学研究的步骤去开展自己的研究。然后是 localization of brain function. Localization of brain function refers to the assignment of functions to particular regions of the brain. Today, the use of functional brain imaging techniques, especially positron emission tomography and functional magnetic resonance imaging, is renewing the issue of localization of function with unprecedented technical precision. Most of the results have partially confirmed the validity for normal subjects of the localization data established earlier in clinical neuropsychology for brain-damaged patients, for example, Broca's area for word production, while nonetheless suggesting that there are networks or neural circuits spanning several brain regions for each function studied. 好，这个就是我摘选的一些重要概念，希望大家可以喜欢。好，这次视频就录到这里。